So in this example, we are dealing with a parallel circuit consisting of 3 resistors. First thing I'm gonna do, I need to find out the equivalent resistance, which will be, using this formula, 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3. That's going to be 1 over 3 plus 1 over 4 plus 1 over 6. So when you add them, you need to find out the common denominator, 6, 4, and 3. That's going to be 12. So we're going to have 4 plus 3 plus 2. 4 plus 3, 7. 7 plus 2, 9. 9 over 12. So 1 over RT is going to be 9 over 12. Divided by 3 is going to be 3 over 4. So RT will be 4 over 3 or 1.33 ohm. So that's the total resistance. If you want to find out I, which is electric current, that's V divided by R total. Voltage is 24, so 24 divided by RT is 1.33. It's going to give me around 18 amps. So here we are dealing with 18 amps. And obviously it is going to be distributed in these 3 branches. However, voltage in each branch is going to be the same. So V1 equals to V2 equals to V3. That's going to be equal to 24 volt. 24 volt, 24 volt, 24 volt. So I1 is going to be V1 over R1. I2 is going to be V2 over R2. I3 is going to be V3 divided by R3. That will be 24 divided by 3, that's 8. 24 over 4, that's going to be 6. And 24 over 6 is going to be 4. So 8 amps, 6 amps, and 4 amps is going to be I1, I2, I3. If you add them all, you can find out this 18 here. Let's check that. 8 plus 6, 14. 14 plus 4 is going to be 18. So that makes sense. So we found equivalent resistance. We found V1, V2, V3. We found I1, I2, I3. Let's find out P1, P2, P3, which is V times I, V times I, V times I. Or you can say V squared over R. Doesn't matter which one you select. It's supposed to give you the same answer. V1, I1. I1 is 8. V1 is 24. So 24 times 8. It's going to be 192 watts. V2 is 24 times I2. I2 is 6. 24 times 6 is going to be 144 watts. V3, I3 is going to be 24 times 4. That's going to give me 96 watts. So the total watts is going to be 192 plus 144 plus 96. That's going to give me 432 watts.